Right. Mm, okay. At the last day, we were discussing. I think we stopped. We wrote the equation for resistance R equals rho L over A equation we learned, and then we discussed about what is resistivity also. Rho resistivity. Uh, I think I explained that, but I think I haven't given any definition for resistivity. We want to start from the resistivity story today. Today we will be doing some nice, interesting questions also. Today we will talk about the equivalent resistance and how to find the result resistance of a resistor circuit. That story we will learn today. Okay, right. Okay, right. Mm, right. So then, first important story is resistance. Then I said that through a conductor, when current passes, current can't easily pass through a conductor. To the flow, there is a kind of barrier against the flow of current. If you can measure that barrier quantitatively, the physical quantity that you defined is the resistance. Simple resistance measures how much barrier that the current has when flowing through the conductor, right? Larger the barrier, we can understand that larger resistance. That's totally clear. And we obtain an equation for electric resistance in terms of resistivity, cross-sectional area of the conductor, and the length of the conductor. That is R equals rho L over A. R equals rho L over A. Story. R equals resistivity rho, length of the conductor simple L over cross-sectional area of the conductor capital A. But I told you that when you are getting a relationship between resistance, resistivity, length, and area, you want to maintain one parameter constant. That parameter must be the temperature, right? So while maintaining temperature constant, the relationship between R rho L A is the R equals rho L over A equation. Temperature must be constant, right? The thing is, when the temperature changes, understand resistivity changes. Sorry, resistance changes. So we will learn how the way resistance changes with the temperature. The story we will learn bit separately. Okay, temperature constant, right? And I told you that resistivity rho is a constant which depends on the properties of the material. Different conductors have different resistivity. I explained last day based on when you consider different conductors, different materials. For example, consider aluminium, iron, copper. When you go to the microstructure, we understand that the atom sizes, atom arrangement, and the void available space all are different from material to material. Therefore, the barrier is different from material to material. That's why this rho is a constant which depends on the properties of that material. Okay, we call it as resistivity. Okay, so then this equation you must learn by heart. Very important equation in current electricity. Very important equation in current electricity. Right. Okay. Now we'll talk a little bit about resistivity and we'll go to today's story. Okay. Right. So when I subject resistivity rho from this equation, rho equals capital R into capital A over simple L. Did we write down a topic named as resistivity? Someone tell me. Did you write a topic named resistivity? Yeah, we wrote a heading resistivity, right? Right. Resistivity can be defined as resistivity can be defined as electric resistance of a conductor. Electric resistance of a conductor. Of unit cross sectional area, and and unit length and unit length, unit cross sectional area and unit length. So when you subtract from this equation r equals rho L over A, when you subtract rho, we get the rho as what? R into capital A over simple A. R is the, okay, uh, when you consider R means what? When you consider the conductor of length simple L. When you consider conductor of length simple L, okay, and the cross sectional area of the conductor capital A, the electric resistance throughout the conductor is capital R. The total electric resistance, the total barrier throughout the conductor is we marked as capital R. Then what is rho? Rho means understand resistivity means, yeah, it's a property depends on the medium. That's correct. But we can define rho as when we consider 1 meter, if a unit length of the conductor, and when you consider 1 meter squared, unit cross-sectional area of a conductor, same material, but if you consider unit length, unit length and unit cross-sectional area, 1 meter squared area and 1 meter length of the conductor, the resistance of the conductor is what we call as resistivity. The resistance of the conductor is what we call as resistivity, right? There is a conductor of length simple L and cross section area capital A. The total barrier is capital R. Total resistance capital R. Resistivity means we can define when you consider unit length of the conductor, 1 meter long conductor having unit cross sectional area, 1 meter squared cross sectional area, the electric resistance, that capital R, the barrier is resistivity rho. Okay, I hope you understand that capital R resistance, that is the resistivity. Okay, then write on this equation also, and write these stories also. Capital R is equal to resistivity. Okay, but simply you understand that resistivity is a kind of constant which depends on the properties of the material. That's more than enough. That's more than enough, right? Quickly, quickly, quickly. Right. So we'll do some questions. We'll do some questions. Question number one, write down. Question number one, write down. A wire of circular cross-sectional area. A wire of circular cross-sectional area is to be made by is to be made by 1 gram of copper. 1 gram of copper. Full stop. Its resistance is 0.5 ohms. Its resistance is 0.5 ohms. and resistivity and density are and resistivity and density are 4.3 into 10 to the power minus 7 ohm meter. Resistivity 4.3 into 10 to the power minus 7 ohm meter. Density this time, now the problem is we define resistivity also with the symbol rho, and we define density also with the symbol rho to separately identify without having any confusion. Let's define the density of the material as simple D. Density is how much? I told you, if the resistivity and density are 4.3 into 10 to the power minus 7 ohm meter and 8.95 gram per centimeter cube. 8.95 gram per centimeter cube. Mass or volume. Come on. Find the length and cross-sectional area of the conductor of the wire. Find the length and cross-sectional area of the wire. Find the length and cross-sectional area of the wire. Find the answer. You should find the length and then cross-sectional area. Capital E. So we learned a new equation, resistance equals rho L over A. And they have given the mass. Mass of the copper wire is 1 grams. Given data. Mass of copper wire is 1 grams. Mass of copper wire 1 grams. Simply means 1 grams. Now find the answer. Find the answer. From the theory that we just learned, since we know R and we know the resistivity rho, but we don't know L and E. In the question, we want to find L and E. That's our target. So what you can do, you can consider that equation R equals rho L over A. R equals rho L over A equation. And R substitute. So going to be 0.5. This rho is 4.3 into 10 to the power minus 7 ohm meters. The length is simple L, area is capital E. But the problem is we can't find simple L or capital E. The reason is there are two unknowns in one equation. Since there are two unknowns in one equation, we can't find L or A. We can't find any of them. So one can do what you can do. You can write down. You can substitute capital A in terms of simple A. If not, you can substitute simple L in terms of capital A. It's up to you. Shall we substitute capital A? If I substitute capital A going to be equal to how much? Capital A going to be equal to 4.3 into 10 to the power minus 7 L over 0.5. Right? So then if you simplify that, you will get that 8.6 into 10 to the power minus 7 simple. But still we can't find simple L or capital E. This is my equation 1. Equation 1. How can we do the next story? If there are two unknowns, we need at least two equations. We need at least two equations. Then what we can do now, we know that mass or volume is equal to density. We can consider this wire as a cylindrical object. Then the cross-sectional area into the length is the volume. So next story we will know that when you apply the equation for the wire, mass over volume equals density. Density equals mass over volume. Volume means volume is cross-sectional area into height. Cross-sectional area into length. Then I can write down density as what? Mass over, sorry, density simple D. Density is what? Mass over cross-sectional area into the length simple L. From this equation, we can get another story. From this equation, we can obtain another relationship between capital E and capital L, simple L. capital A and simple L. I think you can see what I have wrote here. Can see? Yes, simple D must be density must be equal to mass over cross-sectional area into the length. Then when you substitute, what we can do? When you substitute, right? You know capital A in terms of simple L. Substitute for this equation. When you substitute, then we can write down density of the material is 8.95 grams per centimeter cube. How do we convert grams per centimeter cube into kilograms per meter cube? That's important. If they have given a density in grams per centimeter cube, somehow you should convert into kilograms per meter cube. How can we convert? So remember, now 1 grams per centimeter cube, that means what? 1 gram over 1 centimeter cube. How do we convert grams into kilograms? We multiply by 10 to the power minus 3. How do we convert grams into kilograms? We multiply by 10 to the power minus 3. Kilograms. How do you convert centimeter cube into meter cube? You want to multiply by 10 to the power minus 6. 1 centimeter cube, if you want to convert to meter cubes, multiply that 1 by 10 to the power minus 6. Then we can convert 1 grams per centimeter cube must be equal to, if we simplify this, 10 to the power minus 3 over 10 to the power minus 6 means 10 to the power 3. Remember, 1 grams per centimeter cube, learn by heart. 1 grams per centimeter cube equals 1000. If not 10 to the power 3 kilograms per meter cube. So if you want to convert grams per centimeter cube into kilograms per meter cube, multiply by 1000. Multiply by 10 to the power 3. That's story. Okay. Remember the story? Okay. Substitution. Just substitute. If we substitute, then density 8.95 grams per centimeter cube to convert into kilograms per meter cube, multiply by 1000. Equals mass is mass is 1 grams. How do you convert grams into kilograms? You want to multiply by 10 to the power minus 3. If you want to convert grams into kilograms, multiply by 10 to the power minus 3. Okay, over cross-sectional area capital A. From my equation 1, I can write down cross-sectional area capital A as 8.6 into 10 to the power minus 7 L. Capital A means from equation 1, we can write down 8.6 into 10 to the power minus 7 simple L into simple L. So then you will get that simple L squared. Finally, we can write an equation only involving one variable, simple L squared. Now you can find simple L from this equation. Once you found simple L, you can easily find this capital A, right? So if I subject a simple L, that should be equal to we simplify this, do the simplification. When 10 to the power minus 7 goes to the numerator, it becomes 10 to the power plus 7. 10 to the power plus 7 into 10 to the power minus 3 means 10 to the power plus 4. Here 10 to the power plus 3. Here you are getting 10 something in the numerator. At your denominator, you will get that 8.6 into 8.95 the whole root. So this is going to be a simple L. So if you know the simple L value, you can consider equation 1 and you can substitute simple L. When you substitute simple L, you can find the capital A value also. Right? That story is clear, right? Hands up. Up to now, everything is very clear. Hands up. Do the simplification at your home. We don't have time to do the simplification. But the story, the way how we found capital A and simple A, that idea is very clear answer. That idea very clear answer. Did you understand what I'm explaining? Hands up. Just raise your hands if you understood. It's not difficult, right? Can understand. So I only consider two equations. One is the resistance equals rho L over A equation, and I wrote an equation in terms of L and capital A. I realized that only having this equation with two unknowns, I can't find any of the unknown. Then I decided to find another equation involving capital A and L. Then only I realized that density means always mass over volume. Volume means area into the length. Then I wrote another equation in terms of A and L. So then there's a kind of small simplification there. You might have plenty of experience of dealing such simplifications, right? So then finish writing answer. Once you finish writing, raise your hands. Okay. Then write down next question. Then right. Not next question. Next topic. Write down equivalent resistors slash resistance. Equivalent resistors slash resistance. Uh, Now in an electric circuit, understand. Now we all know what is resistor. What is the difference between resistor and resistance? Resistance is a property, the barrier to flow a current. That property is the resistance. What is resistor? The devices that we connect to create a resistance. The devices which create resistance are resistors. Now there is a conductor and there's a current passes through the conductor. Now we want to apply a kind of barrier to the current. You want to apply a kind of resistance to the flow of current. In that case, what you can do, you can apply resistors. Resistors only creates resistance. That story you know. Now in an electric circuit, understand, in our practical electric circuit also, there are so many resistors connected together. So normally we say that when the resistors connect together, we call it as a resistor system. Based on the arrangement of the resistors in that system, we can consider there are two different resistor systems. One is series resistor system, other one is parallel resistor system. That story we will learn in a while. Write down. Write down. When there are two or more resistors, when there are two or more resistors connected together, when there are two or more resistors connected together, come on, it is called to be a system of resistors. It is called to be the system of resistors. It is called to be the system of resistors. Next point, write down. The equivalent resistance of a system of resistors. The equivalent resistance of a system of resistors is the single resistance single resistance that could replace the entire network. The single resistance that could replace the entire network in such a way, in such a way, in such a way that for a certain applied voltage capital V, for a certain applied voltage capital V, comma, it resides the same current, comma, it resides the same current. In such a way that for a certain applied voltage capital V, it resides the same current. Highlight a certain applied voltage, same current. Certain applied voltage, same current. I will explain like this. Can you remember when we were talking about mechanics? We talked about resultant force. Now, can you remember what is the idea behind resultant force? Whatever the result given by set of forces acting on a system, if a single force can provide the same result, then we said that that single force as the resultant of those set of forces. There's an object on the road. There are many forces acting on the object. If I mark them, F1, F2, F3 forces are acting on the object. F1 force, F2 force acting on this object in this direction, and then F3 force acting on the object in this direction. There are lots of forces. There are three forces acting on this object. What is the result? Due to the application of these three forces on the object, the result is very simple. Due to these three forces, this object undergoes an acceleration to the right side direction. The result is this object undergoes an acceleration to the right side direction. Acceleration is 2 ms minus 2, for an example. If I repeat it again, due to the application of these three forces on the object causes undergoing a acceleration of 2 ms minus 2. Whatever the result, what is the result? The result is accelerating with 2 ms minus 2 acceleration at the single force, right? Rather than applying three forces on the object. Let's say now you are applying a force. You are applying a force, let's say for an example, capital if not capital R, you are applying a force capital R. Then I explained that when you apply this capital R force on the object, the result is same as the previous accelerator to the right side direction under simple A, 2 ms minus 2 acceleration. Then we can call that this single force is the resultant of these three forces, because these three people contribute together and produce the result. Same result is going to produce by a single force. Then we can tell the single force as the resultant of these three forces. The same story is applicable in equivalent electric resistance. Just consider circuit. In a circuit, remember there are plenty of resistors. There are plenty of resistors in a circuit. Right? What is equivalent resistance? Equivalent resistance. Resistance. This idea, there is a circuit. That circuit contains a set of resistors. Okay. Now between these 2 points, for an example, when you consider between these 2 terminals, there is a resistor system, set of resistors. For an example, I can draw like this. We know the symbol of resistor. Likewise, there are plenty of I draw some for our understanding, but you try to understand there are lots of resistors in between these two circuit. In between these 2 points, there are lots of resistors in between these 2 points, right? So this is what we call as a resistor system. Okay. So forget about now like this. They are between these two terminals. There is a plenty of resistors, right? Between these two terminals, let's say terminal A and terminal B. I'm not drawing the resistor system between these 2 points, but understand there is a resistor system between these 2 points, right? This is my resistor system. I don't draw the resistor system, but understand there is a resistor system between point A and point B, right? Resistor system. Resistor system. What is the idea? Let's say this resistor system produced a current of capital I, produced a current of capital I through the resistor system under a potential difference, under a voltage difference capital V. This resistor system has created a current of capital I through the resistor system under a potential difference capital V, right? Now we can tell that equivalent resistance means the single resistor, the single resistance which can produce the same result. So what is the result? This resistor, what is the result produced by the resistor system? Produce the current I due to a potential difference capital V. The result is producing a current capital I under a potential difference capital V. If a single resistor can produce same I current and same potential difference, if there is any resistor, if there is any resistance which can produce same result, same current and same potential difference between A and B terminal, between A and B terminal, then we call this resistance as the equivalent resistance of this resistor system. Then we call this resistance, this resistor as the equivalent resistor as this set of resistors. This story is clear, right? Hence, this idea is clear. Whatever the result given by a resistor system, if a single resistor can give the same result, then we can call it as a equivalent resistor. That story is clear, answer. That idea is clear, answer. The idea is clear. Then write down. Write down. What you can do this diagram. This diagram. Just with the diagram. The result is producing I current under a potential difference capital V. The single resistance which can produce the same result produced by this resistor system we call as the equivalent resistance. Just do this diagram for your understanding. Draw the diagram for your understanding. Equivalent resistance. Equivalent resistance. So once you finished writing this story, raise your hands. Once you finished. Once you finished drawing the diagrams, raise your hands. Okay, then you can write down there are two systems of resistors. There are two systems of resistors. Number one, series. Number two, parallel. There are two systems of resistors. Number one, series. Number two, parallel. Number two, parallel. And put a subtopic, resistors in series. Resistors in series. Put a subtopic, resistors in series. Resistors in series. Subtopic. So write down under this topic, when resistors are in series. When resistors are in series, comma, number one write down. Number one write down. Red color pen. The amount of current flow through each resistor. The amount of current flow through each resistor. The amount of current flow through each resistor is same. And is equal to the current through the equivalent resistor. Is equal to the current through the equivalent resistor. The amount of current flow through each resistor is same and is equal to the current through equivalent resistor. Current through equivalent resistor. Highlight current each resistance same. Current each resistance same. Equivalent resistance. Equivalent resistance. Okay. All right. Now second point, red color pen write down. Second point, red color pen write down. The potential difference across the equivalent resistor. The potential difference across the equivalent resistor. Equal to the algebraic sum of potential difference. Algebraic sum of potential difference across each resistor. Now listen to the story very carefully. Now I will tell you how to find the equivalent resistance when there is a resistor system in series. In series means like this. Let's say now there are three resistors in series. Resistor 1, second resistor 2, third one, resistor 3. So between the terminals capital A and capital B. Now understand these are the resistors are connected one by one by using conductive material. By using conductive wire, these resistors are connected one by one. We understand that these three resistors are in series. That's why we call it as resistor system is in series. And when you measure the resistance of this resistor, when you measure the resistance of this resistor, that is capital R1. Resistance of resistor R2. This one is going to be R3 resistance, right? Now let's say, anyhow, remember, this is a kind of conductive wire. It's a kind of conductive wire, right? Kind of conductive wire. Then what happens? If I say that, for an example, don't think the electric circuit beyond point capital B and point capital A, don't think. Just think there is a very big electric circuit beyond point capital B and point capital A. I only have taken a small part of that larger circuit. I have taken a small part from that large circuit. Only consider point capital B and point capital A. For an example, just think that electrons are flowing from B to E. Electrons should flow through B to E. Then electrons are flowing from B to E. The electrons has to pass through R3, and then electrons has to pass through R2, and passing through R1, and only electrons can come to point capital A, right? So then, if the electron flows to the left side direction, we know that direction of current would be from A to B. Therefore, remember, the current is passing through each and every resistor connected in series, right? Whatever the current passing through R1 resistor, if R1, R2, R3 resistors are connected together in series, if these resistors are connected together in series, whatever the current passing through R1 resistor and whatever the current passing through R2 resistor, whatever the current passing through R3 resistor, all are same current. That's obviously. Just think that there is a kind of a water tube, water pipeline, right? So in the pipeline, at three different regions, there are some kind of barrier to flow the current, flow the water. In the water pipeline, at three different regions, there is a kind of barrier to flow against water flow. Right? There's a kind of barrier against the water flow. It doesn't matter even though there's a barrier or not, we know that whatever the water passing through barrier 1, barrier 2, barrier 3 must be same. Okay, same story I want to tell you that in between two terminals, if there are resistors in series, same current passes through each and every resistor. That is the first important story, right? That's why I have given in a point. If the resistors in series, the current passing through each resistor must be same, I, right? And next story I will tell you the equivalent resistance, right? Let's consider the potential difference, if not voltage difference, between point capital A and point capital B. Let's say capital V. The voltage difference between point capital A and point capital B. Let's say capital V. The voltage difference. The voltage difference. Capital V. Capital V. Now then, you might have a small problem. I explained in some theories, I explained how you can provide the potential difference, if not voltage difference. I said that we can connect the battery to the terminals of A and B. Okay, I explained the story. Just take the same circuit somewhere here. What have you done? You connected these terminals A, B to a battery of voltage 5 volts for an example. Battery of voltage 5 volts example. Battery of voltage 5 volts example. I use the battery circuit symbol Positive terminal is large line, negative terminal is represented by a small line, right? Okay. Normally, I don't know if you can remember or not. Normally, we consider voltage, if not electric potential. We can tell voltage, if not electric potential, they are same. Electric potential, different voltage, they are having same idea. Normally, we consider electric potential or voltage at the negative terminal as 0 volts. 0 volts. Then you might have learned that all the points, till when you consider, right now we know that at the negative terminal the voltage is 0 volts, right? So then this negative terminal of the battery is connected to the resistor by using a conductive wire. Remember, entire conductive wire till it meets the resistance, voltage must be same as 0. That's what we will learn. All the points in this conductive wire till they meet resistance must be 0. So if I ask you what is the voltage at this point, 0 volts. What is the voltage at a point somewhere here, 0 volt. What is the voltage at a point somewhere here, 0 volts. Right? Okay. Right. That's to remember. And let's say this battery is having a voltage of 5 volts. Negative terminal is always 0 volts. What should be the voltage? What should be the electric potential at the positive terminal? That must be plus 5 volts. If the voltage is 5 volt battery, if it is a 5 volt battery, 2.5 volt battery, if it's a 2 volt battery, based on that it changes. Now I'm telling this is a 5 volt battery. Negative terminal voltage is 0. Then the positive terminal voltage must be 5 volts. 5 volts. Then when you consider this entire conductive material, till it meets resistance, its potential, if a voltage is always 5 volts, 5 volts, 5 volts. When you consider any point on this conductive material till it meets resistance, voltage is 5 volts, 5 volts. Now this idea you will learn in upcoming stories, but I just better if I can give a kind of brief regarding this, then you will be able to understand the story properly in upcoming sections. Just raise your hands, this idea. If we connect the battery, negative terminal is 0 volts and positive terminal 5 volts, till they meet resistance, voltage remains constant throughout the conductive material. That story is roughly understood answer. The story have roughly understood answer. The story, if you understood answer, right? That story is okay. That story is okay. I will tell you one story. Remember, normally between two terminals, if you connect a resistor, if a current passes through the resistor between two terminals like A and B, if you connect resistors and if there is a current passing through the resistors, remember there is a voltage reduction. There is a voltage drop. For an example, I will tell you that when you consider two terminals, point capital A and point capital B, they have mentioned point capital A voltage is 5 volts. Right? When the current is passing through terminal A to terminal B through a resistor, remember there is a voltage reduction. Just before the resistor, voltage is 5 volts. After the resistor, remember, voltage must be less than 5 volt. This story you will learn. Therefore, an example, 3 volts. At terminal B, voltage is 3 volts. At terminal A, voltage 5 volts. What is the voltage difference across the resistor? It is 2 volts something. Okay, that story. Roughly remember, then you will be able to understand some theories in upcoming sections. And one more story. One more story is, remember, always this voltage drop happens in the direction of current flow. For an example, if the current is flowing to the right side, voltage drop also happens to the right side. Voltage at point A is larger, voltage at point B is lesser. There is a voltage drop to the right side. For an example, if I say current is flowing to the left side direction, for an example, then remember voltage drop happens in the left side direction. If I ask someone, someone asks from you, now they just give a diagram like this. A current passes through resistance capital R, and they tell that which point has larger voltage. They will ask you that. They will give two terminals A and B, and they connect a resistor in between those two terminals. And when a current capital I passes through the resistor, they will ask you that which terminal has larger voltage. Raise your hands. How many of you say, sir, voltage at point capital B must be larger answer. Voltage at point capital B must be larger answer. Voltage at point capital B must be larger answer. Voltage at point capital A must be larger. Voltage at point capital A must be larger answer. That story. Remember always, voltage drop, voltage reduction happens always from direction of current. Okay, that story also keep in your mind. Keep in your mind stories roughly. Then I told you some ideas. The first idea is, remember, when a current passes through resistors, voltage drops. That story, remember. Always this voltage drop happens in the direction of current flow. That story. Okay. Now I was explaining about resistors in series. I explained that between terminals A and B, we connected three resistors in series. Each resistance R1, R2, R3, I told you that if they are connected in series, the current passing through each resistor must be same, I. If you consider potential difference across terminal A and B is capital V, right? Capital V, okay, right. Okay, for an example, just think this point I mark it as point capital C something. This point I mark it as point capital D, right? Potential difference between point capital A and point capital V, that is V. Let's put some values and we'll understand what's really happening here. Let's see that potential difference between point capital A and point capital B is 10 volts something. Maybe 10 volts. 10 volts. As I explained, sir, direction of current from point A to point B to the right side. Then definitely there is a voltage drop because there are resistors between A and B. And also, sir, voltage drop happens to the current direction. Since current is flowing to the right side, voltage drop is also happening to the right side. That means voltage at point capital A must be a larger value, voltage at point capital B must be a smaller value. So for an example, if I consider voltage at point capital A, if I consider voltage at point capital A as, for an example, 10 volts, for an example, 12 volts. So voltage at point capital A, if I explain it as 12 volts for an example, reply everyone, what should be the voltage at point capital B? Between A and B, total voltage difference 10 volts. Voltage at point capital A is 12 volts. To the right side direction, definitely voltage drops. I'm asking what is the voltage at point capital B? What's the voltage at point capital B? Reply everyone. What should be the voltage at point capital B? Reply everyone. What should be the voltage at point capital B? Reply everyone. Respond. Reply everyone quickly. What should be the voltage at point capital B? Any answers? Any answer? You can tell me exact value. You can tell the exact value. Between A and B, total voltage difference 10 volts. Voltage at point capital A is 12 volts. I'm asking, what is the voltage at point capital B? Everyone can answer. So I'm expecting an answer from all of you. Reply. I'm expecting an answer from all of you. Reply. No time. That's the problem. Not responding. Okay. No responses. 2 volts. Simply. Then 12 volts means voltage at point capital B going to be 2 volts. Then only we can have a voltage drop of 10 volts. 12 minus 2 is 10. Then what you can do? Right. Raise your hands. How many we say? Sir, point A voltage is 12 volts. How many of you say, sir, voltage at point C also 12 answer? Sir, voltage at point C must be 12 volts answer. Sir, voltage at point C must be less than 12 but greater than 2 hands up. voltage at point C must be less than 12, greater than point B. Correct me? Maybe for an example, maybe it can be 10 volts. This can be point D voltage is less than 10, maybe 6 volts, then 2 volts. That is the idea. So understand the stories. I think you understood. No idea. No idea. Right? No idea. So then we can understand voltage at point capital A is larger. Voltage at point capital C, voltage at point capital D, the lesser voltage is point capital B. This story you understood. You understood me? You understood the story. Okay. The story is clear. The story is clear. Right? Since current is flowing right side direction, voltage at point capital is larger than voltage at point capital B. So the equivalent story. What is the equivalent resistance? Resistor. Whatever the result we learned between terminal A and B, there is a resistor system R1, R2, R3. Under a potential difference capital V, what is the result given by this resistor system? A current of capital I. Between two terminals, if you connect a single resistor, between those two terminals A and B, if you connect a single resistor, which provides the same result under that same potential difference, the single resistor, which provides the same results under that same potential difference capital V. That means same current I. Result is the current. Result is the current. Under a potential difference capital V, if this single resistor gives a current of capital I, same current, then we can tell that this resistor is the equivalent of these three resistors. This resistor is the equivalent resistor of these three resistors. Resistance of the equivalent resistor, let's mark it as capital R. Capital R. Equivalent resistor. So this is the equivalent resistor of these three resistors in series. The result given by this resistor system under a capital A potential difference is I. This single resistor also under a potential difference capital V, it also gives a current capital I. That's the story. Very simple story. Equivalent resistor. Okay. Right. Okay. Right. This story is clear. Better you write down this story nicely. See, we understood that when resistors are in series, the current passing through each resistor is same I, and the current passing through the equivalent resistor also same I. Same I. Same I. Okay. And also some stories I will tell you, write down. Shall we mark the potential difference across R1 resistor? If we mark the potential difference across R1 resistor, that potential difference, voltage difference is, let's say, V1. The voltage difference across R2 resistor, that is V2. The voltage difference across R3 resistor, that is V3. What can you say about V1 plus V2 plus V3? That must be equal to the total potential difference capital V. So you can write down capital V equals V1 plus V2 plus V3. That's story. V1 plus V2 plus V3. This story clearly? Let's write down. This might be important. Right. Okay. Finish it. So then red color pen important, write down. Red color pen important. Current always passes from high voltage to low voltage. Current always passes from high voltage to low voltage. Inside the bracket, high potential to low potential if you want. Inside the bracket, high potential to low potential. Inside the bracket. Now put a subtopic Ohm's law. The subtopic Ohm's law. Put a subtopic Ohm's law. Ohm's law. Write down Ohm's law. Ohm's law states that current passing between 2 points. Ohm's law states that current passing between 2 points is directly proportional to the voltage difference across what I said. Ohm's law states that current passing between 2 points is directly proportional to the voltage difference across those 2 points. When temperature remains constant. Right? Okay. When temperature remains constant, there's a conductor. Its two terminals are capital A and capital B. The voltage difference between terminal A and terminal B is capital V. The voltage difference. You can put delta V if not V. Under this capital V voltage difference, the current passing through the conductor is capital I. The current passed through the conductor is capital I. Capital I. But you want to maintain temperature constant. When the temperature remains constant, right? Then Ohm said that the current, Ohm said that the current passing to the conductor between these two terminals must be directly proportional to the voltage difference between those 2 points. The current is capital I, that is proportional to the voltage difference. What is the meaning? What is the meaning of that? Now, as I explained already, how are you going to provide the voltage difference by using a kind of battery? So, what is the meaning? Ohm said that current passing through the conductor is directly proportional to the voltage difference, capital V. That means when you are increasing the voltage difference, you can increase the current passing to the conductor. When you are decreasing the voltage difference, you can reduce the current passing to the conductor. For example, earlier you applied the 2.5 volt battery, then the current is, for an example, 2 ampere. Now you connect a 5 volt battery, now the current will be 10 ampere. I hope you understand the story. The story is very simple, right? So what we do normally, a current is proportional to the voltage is proportional to current, right? So then to do the proportionality, we are using constant. That constant is the resistance capital R. To remove the proportionality, we use a constant. That constant going to be resistance capital R. Then we can write down the most important equation in current electricity. V equals IR. V equals IR equation. IR equation. So voltage measured in volts, current measured in amperes, resistance measured in ohms. Right. So write the stories. Write the story. Write the story. Not difficult. So once you finish writing, raise your hands. Very simple story. If there's a conductor, current passing through the conductor is capital I, the potential difference is capital V, V equals IR. R is resistance of the conductor. So once you finish, raise your hands. Okay. Then earlier, when I consider this resistor series, there are three resistors having resistance R1, R2, R3. Shall we find the voltage difference across each resistor in terms of I R1, I R2, R3? Just try to consider each resistor in series. Try to find the voltage difference across each resistor V1, V2, V3 in terms of I R1, R2, R3. Find the answers. Find the answer. Now you can apply V equals IR for any resistor. You can apply V equals IR for a resistor because there's a current passing to the resistor. There is a resistance. Then definitely there is a voltage difference. Therefore, we can apply V equals IR equation. Right? So then we can consider the answer. So when you consider this resistor, I draw it again for our understanding. So this resistance R1, the voltage difference across R1 resistance, if not across AC, that is V1. The potential difference, voltage difference V1. Likewise, the voltage difference across R2 resistance, if not across CD, that is going to be a V2. When you consider point D and point B, voltage difference is V3. Resistance is R3. Current passing through each resistor, that is capital I. Current passing through each resistor, that is capital I. That is capital I. Then what we can do? Now we can consider each resistor and we can apply V equals IR equation. So when we apply V equals IR equation, just apply. If we apply for R1 resistor, V1, if voltage across R1 resistor is V1, current passing through R1 resistor going to be I, resistance R1, IR1. Likewise, when you apply for R2 resistor, so you can name number 1 resistor, number 2 resistor, number 3 resistor, it's up to you. V2 equals IR2. And if you consider R3, V3, voltage difference across R3 resistor must be equal to current into resistance R3, IR3. Okay, is it clear? I take this as my equation 1. It's my equation 2, equation 3. And also just apply this Ohm's law, V equals IR equation for the equivalent resistor. For the equivalent resistor, when you apply the equation, the voltage across the equivalent resistor, that is capital V, that capital V must be equal to current passing through the equivalent resistor is I, resistance R, IR, IR. So look here what I'm doing. So what I'm doing. So then we can tell that this equation I take it as equation simply. Simple equation, the total voltage difference between the terminal A and B must be equal to algebraic sum of voltage difference across each resistor. Algebraic sum of voltage difference across each resistor. V1 plus V2 plus V3 must be equal to the total voltage drop, total voltage difference. When I consider equation simply 1, 2, 3, 4, I can get it. Equation simply 1, 2, 3 and 4, I can write down important story. That is what? An important story is we can write down. We can write down. V means what? From equation 4, I capital R. I into capital R. V means I into capital R. V means voltage difference across equivalent resistor. If not voltage difference across entire resistors must be equal to V1 is what? V1 means here from equation 1, IR1. IR1 plus V2 means from equation 2, V2 means IR2 plus V3 means what? V3 means IR3. Finally, we can cut all these items. Finally, we can write down an expression for equivalent resistor for a resistor system in series. The equivalent resistance of a resistor system in series, we can find an equation. Capital R is equal to what? Equivalent resistance is equal to addition of resistances of the resistors in series. Equivalent resistance equals addition of resistors. Equivalent resistance must be equal to the addition of resistances of the resistors in series. Addition of resistances of the resistors in series is the important story. That is very simple. Hereafter, whenever you identify resistors in series, what you want to do is you want to add them to obtain the equivalent resistance. Hereafter, whenever you see that, when you identify there are a set of resistors in series, just add them together to get the equivalent resistance. This story answer, clear answer. Story is very clear answer. The story is clear answer. The story is clear. Very simple, ni? Then write down. Once you finished, write in raise your hands. Once you finished, raise your hands. Right? Finished? Finished. Raise your hands if you finished. Finished, right? Then just put that sample questions. Find the equivalent resistance. Find the equivalent resistance. Find the equal resistance quickly for below systems. Find them. Find the answers. Find the equivalent resistance. Number one. First one. Always remember you are going to find equal resistance between which 2 points. Always keep in your mind that between which 2 points am I going to find the equal resistance. Based on the 2 points, your equal resistance may be different. Find the equivalent resistance between point AB. So you want to find the equivalent resistance between point AB. This is 5 ohms. This resistance 9 ohms. 1 ohms. Find the answer. Find the answer. We know that resistors in series. Then if I want to find the equivalent resistance, I want to add them together. Then 5 plus 9 plus 1 means directly it's 15 ohms. Capital R going to be 15 ohms. Capital R is how much? 15 ohms. Equivalent resistance. Not difficult. Right? Right. Next story. Next story. Different column and write down a point. Different column and write a point. When there are simple in number of resistors, when there are simple in number of resistors, when there are simple number of resistors with equal resistances, with equal resistance, when there are resistors, when there are simple in number of resistors with equal resistance in series, when there are simple number of resistors with equal resistances are in series, comma, then equivalent resistance can be found by, then equivalent resistance can be found by, then equivalent resistance can be found by. Multiplying resistance, multiplying resistance of one resistor, multiplying resistance of one resistor by number of resistors, by number of resistors, by number of resistors. It's an important point. Special case one, you can put special case one like that. Special case one. Now let's say now there are set of resistors in series, but you notice that their resistances are same. Right? Story. You notice that set of resistors in series. Also, their resistances are same. Just consider between point capital A and point capital B, there are simple number of resistors. I have marked 3 resistors, but understand there are simple number of resistors. That's why I have put some dotted line. There are simple number of resistors. Number of resistors. and all resistors are having same resistance, capital R, capital R, capital R. So the general principle of finding the equivalent resistance is, if there are resistors in series, just add them together to get the equivalent resistance. But if there are 100 resistors, let's say resistance of each resistor is 5 ohms. If you are doing according to the concept, if there are 100 resistors, each having resistance 5 ohms, then what you want to do? You want to put that 5 plus 5 plus 5 plus 5 plus still 100. Rather than doing that, what you can do, you can consider resistance of one resistor and you can multiply by number of resistors. Then you can tell that equivalent resistance, R equivalent means you can tell that must be equal to R into capital N, right? R into capital N. The story. For example, just say, for example, let's say there are 4 resistors in series, each having resistance 3 ohms. Three ohms between point A and point B. So you want to find the equivalent resistance. Then the idea is, if there are resistors in series, we can add them together. You can add the resistances together, then you get the equivalent resistance. You can add the resistances together, then you get the equivalent resistance. According to that, what you can do, you can tell that capital R equals 3 plus 3 plus 3 plus 3. Capital R equals 3 plus 3 plus 3 plus 3. That is going to be 3, 6, 9, 12 ohms. But no need to do like this. What you can do, if you notice that if the resistors are in series and all the resistors are having same resistances, then what you can do, you can tell that magnitude of one resistance, that is 3, number of resistors 1, 2, 3, 4, when you multiply by 4 also, you are getting the same answer, 12 ohms. Right? 12 ohms is the idea. Same story. And it's very clear, right? It's very clear. Now, little by little, I'm telling you some important points. Now, okay. Now we understood what is equivalent resistor. I told you that what is the meaning of resistors in series, how to find the equivalent resistance. That story also I explained. And then this story, this example, right? Okay. Super red color pen writer important. Super red color pen writer important. Anyway, the story you will learn in upcoming stories also. Write down a system of resistors in series. A system of resistors in series. A system of resistors in series is considered as the potential divider circuits. 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 That idea I will tell you, don't worry. Okay. A system of resistors in series is considered as a potential divider circuits. Right? Okay. What is the meaning of that? What is the meaning of potential divider circuit? Look here. Look here, the story. Very carefully listen. Now, first of all, I take some numerical values and I will tell you the idea. Then I will go the symbolic method. Just consider two resistors. Just consider two resistors. Just consider two resistors. Okay. Okay. Right. Right. And this point let's mark as point capital A, this terminal point. This terminal point, let's say point capital, this is capital B, capital C. This point is capital C, ABC, press AB. And let's say resistance of this resistor, let's take it as R1. Let's take it as R1. R1 value I just mark it as 5 ohms to understand the idea. What does it mean by potential divider? Potential divider means by the name itself you understand that it divides, this circuit divides the potential. This circuit divides the resistors in series. That circuit divides the potential. That circuit divides the voltage. R1 is 5 ohms. This resistance R2. R2. Let's mark it as R2 as 15 ohms. R1 is 5 ohms. R2 is 15 ohms. R2 is 15. Okay. Story. Now see the idea. The potential difference between terminal A and B, I marked as capital V. The total potential difference between terminal A and B, I marked as capital V. Total potential difference. Okay. That is capital V. Listen very carefully. Story. That is capital V. So we can consider the potential difference between A and B, capital V, that is equal to, for an example, 20 volts. 20 volts. 20 volts. 20 volts. 20 volts. Very simple. Two resistors in series between A and B terminals. Each resistance are 5 ohms and 15 ohms, R1, R2. Potential difference between the terminals 20 volts, capital V. Right. Okay. Right. So what you can do now, let's say in a question, sometimes they ask you, they give the resistances and they tell that potential difference between A and B is 20 volt. They give the total voltage difference. They give the total potential difference. And they ask you to find the potential difference across R1. They will ask you to find the potential difference across R1. They will ask you to find the potential difference across R2. They will ask you to find the potential difference across R1. And they will ask you to find the potential difference across R2. Let's say potential difference across R1 is V1. Potential difference across R2, let's say V2. Let's say V2. Right? V1, V2. V1, V2. So now we know the theory. If the resistors are in series, the current passing through each resistor must be same. Whatever the current passing through R1 resistor must be the same as the current passing through the R2 resistor. I mark the current passing through each resistor as I. Current passing through each resistor is I. Current is I. Current is I. Current is I. Now I'm going to explain why do we call it as a potential divider. I want to teach you why it is called as a potential divider. Right. Now understand. Look here. Now, just do the diagram. Once you finish drawing the diagram, don't you put the values, just roughly do the diagram. Do the diagram. So, now my target is I want to find V1 and then I want to find V2. I want to find V1, then I want to find V2. So what I do now, I can apply V equals IR equation for this resistor. For R1. If you apply V equals IR equation. So when you apply V equals IR equation, voltage difference across R1 resistor, that is going to be V1. My target is to find V1. Current passing through the R1 resistor is, that is I. Resistance R1. R1. Okay. Equation 1. Likewise, consider R2. Consider R resistance. When you consider R resistance, then apply V equals IR. If you consider R resistance, when you apply V equals IR equation, voltage difference across R2 resistance is V2. And then current passing through R2 resistance is I. Resistance is R2. Equation 2. Okay. From equation 1 and 2, I can divide 1 by 2. So I will tell you one story. 1 by 2. If we divide 1 by 2, we can write down V1 to V2 ratio must be equal to V1 to V2 ratio must be equal to IR1 over IR2. IR1 over R2 ratio. Current cancel out, II cancel out, then we can write down V1 to V ratio. When resistors are in series, remember first important story, when resistors are in series, first important story is remember, since the same current passing through both of them, when resistors are in series, voltage ratio always equal to their resistance ratio. V1 to V2 always equal to R1 to R2. One story. Always remember, voltage difference across the resistors ratio must be equal to the resistances ratio R1 to R2. One story. One story. One story. Okay, this is one story. Let's say now I want to find V1. Now I want to find V1. So we know R1 value, we know R2 value, we know capital V value, but I don't know I value, right? And I don't know V1, I don't know V2. I want to find V1 now. So what can I do? I can write down V1 in terms of V2. I can write down V1 means what? I can write down V1 as V1 means R1 over R2 over R1 over R2. Sorry. Let's write V2. Now I'm going to find from this equation, I'm going to find V2 in terms of V1. I'm going to find V2 in terms of V1. Then my V2 going to be, when you substitute V2 going to be, remember, V2 going to be equal to R2 over R1, R2 over R1. V2 must be equal to R2 R1 dot V1. V1. Okay. This is, I take it as equation 3. Equation 3. Already you learned some important story. When the resistors are in series, since same current passes through each resistor, their potential difference ratio must be equal to the resistances ratio. V1 to V2 must be equal to always R1 to R2. My target is I want to find V1 exactly. I wrote V2 in terms of V1. Real story. We know V1 plus V2 means always equal to capital V. We know V1 plus V2 is always equal to capital V. Am I correct? Then we can tell you that. Next story. Capital V equals V1 plus V2. That story is agree. V1 plus V2. V1 plus V2. And now what we can do? We can do the simplification. Now I will do the summary. Summary is very simple. On the derivation, I will do the summary. That is very simple. Then capital V going to be equal to V1. I want to find V1 only. V2 means I wrote in terms of V1, my V2. V2 I wrote as V1. V2 is going to be equal to R2 to R1. R2 over R1 dot capital V1. Capital V1. Okay. Now you can find, now you know V value, it's 20 volts. You know R1 value, you know R2 value. Only unknown is capital V1. You can find that. So when you take V1 as your common factor out, then V1 going to be how much? Right? R1, we simplified. We simplify this. Common denominator is R1. Somehow you are ending with R1 plus R2. R1 plus R2. So finally, when you substitute V1, Finally, when you substitute V1, you are getting a V1 as what? The V1 equals, remember, important story, R1 over R1 plus R2 dot capital V. Dot capital V. Dot capital V. Right? This is the summary. So I will tell you the story. The story. Likewise, if you find V2, now write the stories. I will give a summary in the end. Don't worry. Likewise, if you find the V2, likewise find V2. From the equation 3, you can write down now V1 in terms of V2. If you write V1 in terms of V2, if you write V1 in terms of V2, now you wrote V2 in terms of V1, we wrote V1, subject V1, then V1 is going to be equal to what? R1 to R2, R1 over R2, R1 over R2 dot V2. Okay. Now substitute in this equation, V equals V1 plus V2. We know V equals V1 plus V2 equation. When you substitute, capital V must be equal to, now V1 means R1 over R2 capital V. This equation what? From equation 3 dash something, V equals V1 means R1 over R2 dot V2 plus V2. Somehow when you substitute V2, you will end up with your V2 going to be equal to, remember, R2, we simplify it, R2 over R1 plus R2 dot capital V. R2 over R1 plus R2 dot capital V. Dot capital V. Right? Highlight. Now I can deliver conclusion. These derivations are very clear answer. Conclusion I will explain, don't worry. The derivations are clear answer. These derivations are clear answer. How the way I obtain this derivation answer? They are clear. They are clear. Once you finish, raise your hands. Very simple. When there are resistors in series, first of all, to understand the concept, initially I have taken only two resistors. When there are two resistors in series, if we apply a potential difference between A and B capital V, resistance R1, R2, we notice that the voltage difference across each resistance V1, V2. We notice that V1 to V ratio, the voltage difference across each resistor, the ratio, going to be equal to the resistance ratio, right? R1 to R2, V1 to V2 must be equal to R1 to R2. Now let's say now if they ask us to find the V1 value, voltage across R1 resistor, then what we can do, V1 means R1 over total resistance. R1 plus R2 means total resistance between A and B. R1 plus R2 means we identified it's a total resistance. Total resistance. Total resistance. Am I correct? Total resistance. Right? into the total potential difference. But if you want to find V1, you should divide R1 by the total resistance and you want to multiply by the total potential difference. If you want to find V2, you want to divide the R2 by total resistance and you want to multiply by capital V. Capital V. Right? Okay. This story. We'll do one sample question and we'll come to the conclusion. We'll do one sample question and we'll come to a conclusion. Find the potential difference across each resistor. Find the potential difference across each resistor. Find the potential difference across each resistor. Find this answer. Sample question. Huh? There are two resistors in series. One is let's say 2 ohms. Other one is let's say 4 ohms. Is point capital A, point capital B. The total potential difference between A and B they have given us how much? 12 volts. The total potential difference they have given us 12 volts. Given data. Then find the potential difference across each resistor. Now you can directly use these equations. You don't want to derive from the beginning. So if I want to find the voltage difference across 2 ohm resistance, this resistor, if I want to find the potential difference across this resistor, let's say it is V1, sir. It is V1. It is V1. So potential difference across 4 ohm resistor, that is V2. My target is to find V1, V2. So V1 means very simple. I want to divide this V1 belongs to 2 ohms. I want to divide that 2 ohms by the total resistance. Total resistance is going to be 6. 2 plus 4 is 6. I want to multiply by the total potential difference 12. So then it's going to be, sir, how much? So it's then going to be how much, sir? It's going to be 4 ohms, 4 volts. So likewise, if I want to find the V2 voltage difference across 4 ohm resistor, that is V2. V2 is equal to how much? If you divide resistance 4 ohms by the total resistance 6 ohms, 4 over 6 and multiply by the total potential difference 12, you will end up with how much? 8 volts. But remember, you don't want to do something like this also, because already you learned that always voltage ratio is equal to the resistance ratio. V1 to V2 ratio is equal to R1 to R2 ratio. Now see, you can think that, sir, I want to find V1 and V2. This resistance 2 ohms, this resistance how much? 4 ohms. Total voltage difference 12 volts. Somehow this voltage should be divided for each resistor such a way following this ratio, right? This 12 volts should be divided into these two resistors. This 12 volts should be divided into these two resistors such a way following this resistance ratio. If the resistance ratio is 2 to 4, 2 over 4. What is the resistance ratio? 2 ohms over 4 ohms. 2 over 4. That means 1 over 2. So resistance ratio is 1 over 2. So I noticed that in the circuit, the resistor ratio is 1 to 2. 1 to 2. Resistor ratio is 1 to 2. Resistor ratio is 1 to 2. 1 to 2. Then this voltage also should be divided into 1 to 2 ratios, right? For an example, you have a cake. You say you have a cake, you are having a 12 pieces of cakes. There are 12 pieces of cakes. 12 pieces. There are 3 people. There are 2 people. There are 12 pieces of cake and there are 2 people. And you came to a kind of mutual agreement that from that cake, we should divide 1 to 2 ratio. Entire cake I need 1, entire cake I need 2. 1 to 2 ratio. You are going to divide the cake. But how much pieces you will get? there are 12 pieces in the cake, you should divide it by 1 to 2 ratio. Then how much cake will you get? 1 to 2 ratio means 4 to 8. 4 to 8. 4 pieces for me, 8 pieces for you. That is the idea. Right, by looking at this resistors also, you should be able to, when you're doing MCQs, you understand. By looking at this resistances, you should be able to tell that as a resistors are in series, resistances ratio is 1 to 2. 2 or 4 means 1 to 2. Then this given total voltage difference is 12 volts. That should be divided into 1 to 2 ratio. That means this voltage difference should be 4 volts. This voltage difference should be 8 volts. 8 volts. That idea clearance. That idea clearance. That idea is very clear, answer. That idea is very clear. That idea is very clear. Right? I hope you understand, right? The story is clear. And that's why we are calling resistors in series as a potential divider, voltage divider. The reason is when there are resistors in series, we can break a given voltage into desired sub voltage value. See, 12 volts, we are able to divide into 4 volts and 8 volts. When the resistors are in series, we can call it as potential divider. The reason is this resistors in series divide the total potential. This 12 volt is divided as 4 volts and 8 volts. That's why we are calling it as potential divider. That's also very clear, I think. If there are only 2 resistors, is the idea. Now we are not deriving. If you have time, you just do it. Suppose if there are 3 resistors in series, if there are 4 resistors in series, if there are 5 resistors in series, how are you going to find the voltage ratios? How are you going to find the voltage ratios? That story. That story also write down. That story also write down. Write down when there are 3 resistors in series. When there are 3 resistors in series. Before that, I hope you guys wrote me. Okay. Write down next story. When there are 3 resistors in series. When there are 3 resistors in series. Now can find it. Find them. Find them. When there are 3 resistors in series. This is R1, R2 resistor. This one going to be the R3 resistor. Find the equation. R1, R2, R3. It's the total potential difference across A to B. Total potential difference across A to B. Let's mark it as capital V. Total potential difference. A to B, capital V. Right. They're asking us to find the voltage difference across R1 resistor, but same current passes. Same current passes through each resistor. And they're asking us to find the voltage difference across each resistor. Voltage difference across each resistor. You want to find V1, right? You want to find V2, and then you want to find V3. Just in given data, R1, R2, R3 given data, capital V is a given data. R1, R2, R3 given data, capital V is a given data. You want to find V1, V2, V3. You want to find V1, you want to find V2, and then you want to find V3. That's your target. Is your target. Current passing through the resistors, just mark it as II, same current. Same current. Same current I. From this previous story, when there are 2 resistors in series, how to be you can find the voltage difference across each resistor. That story you can apply for this story also, right? If there are only two resistors, how the way you found V1? You took the corresponding resistance R1, you divide by the total resistances and you multiply by the total potential difference. Same story you are going to do, you can do the derivation later. But if I do the equations, we can take V1 as V1 is what? V1 is corresponding to R1 resistance. V1 corresponding to R1 resistance. R1 over total resistance. R1 plus R2 plus R3. The total resistance, equivalent resistance, R1 plus R2 plus R3. R1 plus R2 plus R3. Then we multiply by the total potential difference, capital V. We multiply by total potential difference, capital V. How to find the voltage across each resistor when they are in series? V1 means voltage across R1 resistor is equal to R1 over total resistance into the total potential difference. Total potential difference. Likewise, if you want to find V2, voltage across R2 resistor, that is equal to R2 resistance over total resistances, total resistance R2 over total resistance R1 plus R2 plus R3 into total voltage difference, capital V, into capital V, into capital V, capital V, right? Likewise, if you want to find the voltage difference across R3 resistor, that is V3, V3 must be equal to R3 resistor, R3 resistance over total resistance, R1 plus R2 plus R3 into the total potential difference, capital V, into the total potential difference, capital V, is the idea. So when there are four resistors in series, now when there are two resistors, we learned to find V1, V2. When there are three resistors, to find the V1, V2, V3, we learn the story. When there are four resistors, let's say there are four resistors in series, which having resistances R1, R2, R3, R4. Corresponding potential differences across each resistor are V1, V2, V3, V4. The total potential difference across those four resistors is capital V. Then tell me V1. V1 means R1 over R1 plus R2 plus R3 plus R4 into capital V. V2 means R2 over R1 plus R2 plus R3 plus R4 into V. V3 means R3 over R1 plus R2 plus R3 plus R4 into V. V4 means R4 over R1 plus R2 plus R3 plus R4 into V. That is the idea. Story clear, answer? Story is clear. Story is clear. Story clear, ne? Once you finish writing, raise your hands. Once you finished, raise your hands. Finished. Right. So then this story also done. I think theory-wise, resistors in series, this is the theory. We can do lots of questions. Right. Sample question one, write down. Sample question one, write down. Find the voltage of the battery. Find the voltage of the battery. maintain a 10 ampere current, to maintain a 10 ampere current, to maintain a 10 ampere current in the below circuit, in the below circuit, in the below circuit, in the below circuit, right? Now they have given a circuit like this. They have given a circuit. There are three resistors in series. So one is 2 ohms, other one is 3 ohms, and this one is 5 ohms resistance. 2 ohms, 3 ohms, 5 ohms. And this is connected to a battery, because why are we creating this resistor series to a battery? To provide a potential difference, because battery is the person who provides the potential difference to a circuit. So in order to obtain a potential difference between point capital A and point capital B, we are connecting these resistors in series to a battery in the aim of obtaining a potential difference, right? Keep the story in your mind. The question they're asking, what is the voltage of the battery? That means what is the potential difference given by the battery? What is the potential difference given by the battery? I'll give some time. Once you finish finding, raise your hands. They mentioned that current passing through the circuit is 10 ampere. The current passing through the circuit, the current passing through the resistors is 10 ampere. Once you finish, answer. We finish finding the answer, raise your hands. It's not difficult. You want to find the potential difference between A and B, that is equal to the voltage of the battery, because voltage of the battery only equal to the potential difference across A and B. So you want to find this V. Current is, they mentioned 10 ampere something. 10 ampere current is passing through each resistor. 10 ampere, 10 ampere, 10 ampere current. 10 ampere current. If you finish finding the answer, raise your hands. If you finished finding the answer, raise your hands. If you finished finding the answer, raise your hands quickly. Not difficult. Very simple story. Not difficult. Find the answer. Finished? Raise your hands if you finished. Very simple, right? Because here we understand that there are different ways. There are different ways to get the answer. So what's one can what someone can consider? So since current passing through each resistor is 10 ampere, 10 ampere, 10 ampere, we can find the potential difference across 2 ohms by applying V equals IR. We can find the potential difference across 3 ohms by applying V equals IR. We can apply the potential difference across 5 ohms by applying V equals IR. When we add those potential differences, that must be equal to capital V. One can do like that. Even one can consider, sir, since these three resistors are in series, what we can do, rather than writing these three resistors in series, we can draw the equivalent resistance in terms of, we can write the equivalent resistance. And then we can replace these three resistors by the equivalent resistance. 2 plus 3 plus 5, 10 ohms, right? Different people can do different things. Then the equivalent resistance between A and B is going to be 10 ohms. It seemed like you have kept a 10 ohm resistor between A and B. It seemed like We have kept a 10 ohm resistor between A and B. The total resistance between A and B is 10 ohms. The current passing through the resistor is same as 10 ampere. Current doesn't change. When you are finding the equivalent resistance, current is same as before. Same current. 10 ohms, 10 ampere current. Then you want to find the potential difference capital V. We can apply V equals IR equation. So when you apply V equals IR equation, you get the answer. V equals IR equation, you get the answer. Current is 10 ampere. The total resistance is 10 ohms. The final answer going to be 100 volts. Very simple. Hands up. Who got this answer? Hands up. This answer, who got answer? This answer, how difficult answer? It's very simple. Not difficult, very simple. Simple story. Simple story. Simple story. So we'll do one more question. Then we'll talk about resistors in parallel. We'll do one more question. There are two bulbs in series. There are two bulbs in series. Full stop. Each bulb has potential difference of 3 volts. Each bulb has potential difference of 3 volts and resistance 1.5 ohm and resistance 1.5 ohm and resistance 1.5 ohm. Find the total resistance of the circuit. Find the total resistance of the circuit. Find the total resistance of the circuit. Find the answer. Find the answer. I'll give some time. Find the total resistance of the circuit. Find the answer. Finished answer. Finished raise your hands. If I repeat the question again, there are two bulbs in series. Full stop. Each bulb has potential difference of 3 volts and resistance 1.5 ohms. Full stop. What must be the voltage of the battery? What must be the voltage of the battery? Full stop. First question is what must be the voltage of the battery? The second thing is find the total resistance of the circuit. Find the total resistance of the circuit. Okay. Find the total resistance of the circuit. Once you finish, raise your hands. It's not difficult, very simple. If you finish, raise your hands. If you finish, raise your hands. Right. Now, very simple. they mentioned they mentioned two bulbs in series. Each bulb has potential difference 3 volts. Same question. Two bulbs in series, 3 volts and VAR is 1.5. What about the total voltage, the total resistance? Now there are two bulbs in series, right? Resistance 1.5 ohms, 1.5 ohms, right? And then this is point capital A, this going to be point capital B. And then potential difference across each resistor, they have given us 3 volts, 3 volts. Then we know that the total, what is the voltage of the battery? 3 plus 3, 6 volts. The voltage of the battery must be 6 volts, right? Battery voltage must be 6 volts, right? And they're asking the total resistance of the system. I found the total voltage. If you want to find the total, sorry, they're asking us to find the total resistance. Then 1.5, 1.5, it's 3 volt, 3 ohms. Very simple. 1.5, 1.5 means 3 ohms, right? Total resistance, let's say R is 3 ohms. Then let's say if you want to find the current pass into circuit, capital I, what you can apply V equals IR equation and V equals 6 and I is I want to find, R is 3, likewise I is 2 something, right? Clear? The story is clear. Just raise your hands. Everything that we discussed regarding resistors in series, everything is crystal clear answer. Everything is very clear answer. Everything is very clear. So then we'll take a small break and we'll start discussing resistors in parallel. Then we'll talk about how to find the equal resistance of electric circuits. Right? Take a break and come. Come at 9:10 something. Come at 9:12. Come at 9:13. Come at 9:13. Uh, okay, now listen. Now tomorrow we are writing that paper also, final paper also. We can't skip writing papers. And tomorrow I thought I plan to do 7 to 11. Tomorrow we'll write the paper. It's tomorrow there is an MCQ paper. MCQ paper is from 7 to 9, right? 7 to 9. We will start again this electricity theory 10 to 12. First Friday we don't do the theory class. Friday we are doing the discussion. And Saturday also daytime I will do the discussion of that last essay paper I could not discuss. There was Saturday evening that last week essay paper I will discuss. And then Saturday night also theory class is there. Sunday also theory class. Monday night theory class. Tuesday night theory class. By the end of the Tuesday, I think that we can finish this electricity almost. Right? Almost I think we can finish. Right. Now what shall I do now? Resistors in series discussed fully. Then resistors in parallel. That story only want to discuss. Right. So let's say now I'll stop for now. Tomorrow we'll again we'll write the paper. Come and write the paper definitely. And tomorrow 10 p.m. onwards, 10 to 12, we'll do the theory again. Right. So then I'm stopping the class for now. Tomorrow we'll continue the class again. Okay. So then see.